Welcome back. We're talking about 1.4 multi-step equations now. We're going to be solving equations involving 3 or more steps. Alright, now a little word about simplifying versus solving. We've talked about this in class a little bit, but just to help drive home the point a little bit more here. Okay. When we're simplifying, basically you're doing exactly what the word implies. You're going to take something that looks complicated and make it look simpler. Alright, now when we simplify, we're going to combine like terms using the signs we have, or possibly distribute, but obviously we don't have any of that here. So simplifying 4x minus 5 plus 2x plus 7. Alright, well, as we've done, say, hey, look at those two guys are like terms. So positive 4x and positive 2x makes a positive 6x. And then likewise, I've got a negative 5 and a positive 7. Okay, again, I've got different signs, so I subtract to get a 2. And then the larger number has a plus sign, so it's a positive 2 there. And 6x and 2 are not like terms, so we stop right there. Okay, now solving, notice what I've done here. I've got 4x minus 5, but instead of a plus, like we have here on the left, I put an equal sign there instead and have 2x plus 7. So it's really the same, but when I'm solving, I want to cancel things using opposite operations, because now we have two different sides as opposed to just one big mass of stuff because of that equal sign. Alright, so basically what we do here, again, you have 4 good moves, but my preference is to cancel the smaller variable first, so that's what I'm doing. So I've got a 2x now, minus 5 equals 7, and hopefully you're on autopilot here. Just add 5 to both sides, get 2x equals 12, divide by the 2, and we get x equals 6. Okay, so maybe it seems like a very subtle difference between the two, but it's a major difference on how you handle those things. Okay, now today's lesson is going to be about solving, so we're going to be doing a lot of canceling. However, we are going to do some simplifying at the same time. So we are going to be doing some combining. So both are going to happen at the same time. You just got to make sure you're paying attention to which one you need to do and when. Alright, let's go. Alright, now I'm going to give kind of this list for a method here for solving equations. Okay, number 1, we're going to distribute if possible. Then we're going to simplify the left side of the equal sign if possible, and remember that means combining like terms. Same thing with number 3, we're going to simplify the right side, combining like terms just on the right side by itself. And then from there we should be solving normally, and really if we followed 1, 2, and 3 well, the worst thing we should have is an equation with variables on both sides. Alright, so here we go, let's follow the steps. Okay, number 1, I'm going to distribute if possible. So looking here on the left hand side, I definitely have a distribution, so I'm going to distribute my 3 into my parenthesis, giving me a 3x plus 12, and then I'm just going to bring down the minus 6. Okay, so that's basically step 1, and bringing everything else I didn't do anything with there. Alright, now 2 is simplify the left side of the equal sign. So here's my left side. Do I have any like terms over there? I sure do. I've got this positive 12 and this minus 6. Okay, positive 12 minus 6 is a positive 6, so that leaves me with a 3x plus 6 over here. Alright, so I simplify the left side. Simplifying the right side, well, 33 is just a single number, so I can't really do anything with that. Okay, now again, I've done as much simplification as I can on the left, and there was none to do on the right, so now I just solve normally. So looking at this guy, hopefully you just immediately think, hey, it's just minus 6 on both sides there, because it is. So then you get 30x equals 27. Divided through by 3 gives us a nice pretty 9. Yay! I knew you'd be excited. Alright, but that's all there is to it if you just follow the method. Again, it's like a free throw shooter. As long as you do the same routine every time, you're more likely to make it. So if we do the same routine here with these equations, we're going to be more likely to get them right. Alright, let's take a look at another one here, just for a little extra practice. Okay, I've got kind of a messier looking scenario here, so let's go. Okay, first again, distribute if possible. Okay, I've got no distribution on the left, so I'm just going to recopy what I have. Yes, granted, if you wanted to, you probably could have done a little something, but I'm going to try to stick to my steps as best as I can here. Okay, which means I'm going to distribute my 3 into 3x plus 18, and then I've got that plus 8 that I'm just going to bring down. Okay, so basically, distribute if possible, done. Now I'm going to simplify the left. Okay, on my left side, I've got a positive 9x and a positive 2x. Those are like terms. They give me a positive 11x minus the 14. Okay, so simplify the left as much as I can. Simplifying the right now. I've got a 3x and then I've got a positive 18 and a positive 8. And if I add those two guys together, because they're on the same side, again, notice I'm not doing any canceling here. That's going to be 3x plus 26. So now I'm done simplifying the right. And now again, solving normally. So again, I do have the equations on both sides, or the variables on both sides thing with my equation. So Again, I like to cancel my smaller variable first, although again you don't have to, it's just my preference. And I get my 26 here. Okay, at this point adding 14 is my only really good move. So I've got 8x equals 40, and then dividing through by 8 leaves me with x equals 5. Alright, there you go. So now I've solved normally. Alrighty, depending on how you felt about that last one, you may or may not need to see this, but there's one little thing at least that I want to point out, so here we go. Alright, so now looking at this, okay, again, we're going to distribute if possible, and I certainly have some distribution, so I'm going to distribute here and here. Alright, so for the left distribution, I got 7x plus 28. Okay, now the right side one is the one I really wanted to point out. Remember, this 3 has a negative sign attached to it, so you are distributing a negative 3. So negative 3 times x is a minus 3x. And then the one people tend to mess up on is this negative 3 times the 12. Since the 12 is negative, it's going to give me a positive. Negative times negative gives me the positive, and 3 times 12 gives us a 36. Okay, that minus sign is a big mistake people tend to make, so just be careful and don't make that mistake yourself. Okay, then we got the 64. Okay, now at this point, I've got a whole lot of stuff going on the left-hand side, but not a whole lot, and basically nothing going on the right. But on the left-hand side, we've got this 7x with this minus 3x, which is a positive 4x. And then I've got this 28 and this 36 getting together, and that's going to be something along the lines of a positive 64. And that equals 64 over there. That's kind of weird. Alright, so now as I subtract the 64 off the left, by kind of coincidence, I'm subtracting 64 off the right, which is the same exact number we have there. Okay, now don't freak out. As these two guys cancel on the left, I'm left with 4x equals 0. Okay, now don't freak out if you see the 0, because it's just a number, and he needs to live too. So at this point I just divide by 4, because really I don't even care what's over there. If I see 4x equals something, I have to divide by 4 to get the x by itself, and so we just do that to the 0 as well. Alright, so that leaves me with x, and of course 0 divided by 4 is simply 0. Alright, so kind of a couple weird things there. Distributing the negative, and then getting an answer of 0. Admittedly, we don't do that very often, but hey, it's a legitimate answer. Now there is another couple of things that can go a little bit weird with these, and it's a whole different class of things, and it's the no solution versus identity scenarios. Okay, so let's get rolling with this. An equation has no solution if the variables cancel each other out and a false statement remains. Alright, so this one doesn't look terribly weird from the start, but as we start going through our steps here, I'm going to 6x plus 14 equals 6x plus 5. So it's right about here. Maybe something in your brain goes, hey, something's up. Because now as I try to cancel one of my variables, I'll cancel the 6x off of the right, but hey, notice what happens on the left as well. Those guys and those guys all completely cancel out, and I'm left with 14 equals 5. Alright, and well, I'm pretty sure that 14 and 5 aren't the same thing, so that's just kind of a weird sort of deal. But what that means, as we can see up here, is it's no solution, because that's certainly a false statement that remains. And in a more kind of English translation, I suppose, is what we got going here is no matter what number we pick for x, okay, we can never find one that works. Okay, I don't want to do this in the video just because it'll take a lot of time. If you want to see it, ask me in class. But okay, if we start picking an x value and plug it in both and crunch both sides, it's never going to work out to be the same thing. We'll get different numbers besides 14 and 5, but we're always going to get some crazy thing that doesn't match when we work it out. And again, what that means is we're going to say no solution. Okay, that's one way of saying the final answer. You might also be familiar with the no solution symbol, which is just a circle with a slash through it. So I'll accept either one of those two as a final answer. You don't need to give both, just whichever one you think looks best. Alright, so the other weird case is an identity, and it's an equation is an identity if the variables cancel each other out and then a true statement remains. Alright, so again, this one doesn't probably look very weird from the start, so we start working it out. Alright, we get an 8x plus 24, and then we're going to distribute here and get a 36, and then a minus 8x equals our 60 over there. Okay, again, looking at a very, very messy left side, I see some like terms, and I've got this positive 8x and this negative 8x, and heck, those guys cancel each other out completely because they're opposites. Basically, they give you 0x, And it's kind of silly to write a 0x because 0 times anything would be 0. So one way or another it cancels out. And then we've got this positive 24 and this positive 36, and if I add those together I get 60. Okay, so that's everything that's left on the left-hand side, and then I've got the 60 that comes down on the right, and like, hey, that matches. Well, I'm pretty sure that 60 is 60. So there's our true statement, so this is an identity. Okay, now one thing that maybe is a little bit weird compared to the last one, for an identity, the solution that we give, our final answer, is basically saying all real numbers. Okay, so what that means is no matter what number we pick for x, everything works. Or every number works. Alright, so again, I don't want to do this in the video because that's going to take a lot of time, but just if we picked a random number like 375 and plugged it in for both x's and crunched the numbers, we would actually get 60. Again, I don't want to do this in the video, but if you want to see it, I'll be happy to do it for you in class. So again, what we're going to say as our final answer here is all real numbers. Alrighty, there's our try these problems. We're just going to go with 2 of them for today because quite honestly these do take a little bit more work and a little bit more time. So there you go. Good luck, and I'll see you in class.